Boston Dynamics announced yesterday with much fanfare that Atlas is dead. And then, of course, today they announced that Atlas is reborn. So, my topic for yesterday was going to be does this mean they're moving in the direction of Optimus? And today we already have the answer. But joining me to discuss this is robotics expert and all around great guys, Dr. Scott Walter. He's going to talk us through it. I'm Brian. Welcome to Future Raza. So let's give us a quick 60-second background on your background so people understand why you're all over the internet today in the last couple days talking about robotics so much.
Yes. So I spent basically the last 4 decades working in the area of robotic and factory simulation. So I've seen just about every robot kinematic that's been out there. In the past 2 years, I've been looking at all the humanoid robots and analyzing them from a kinematic standpoint and also the usability, how they could actually be used in the factory. And the other thing, I'm glad to finally be invited onto your channel, Brian. This is the first time I've been on it.
That's right. You've never been on Futuraza. I understand you were on My Tesla Weekend a few times, but that's
Yeah.
different.
Yeah.
That's so
That's
different.
different. Exactly.
I
Exactly. One
mean,
more for my checklist.
that's right. This guy had the same lemon tree and this whole thing going on. But, hey, what are we going to do? It's great to finally have you on the channel.
Same
So,
here.
yeah, I think that's exciting. The important takeaway here is you're not one of those armchair experts. You're an industry expert.
Yes, yes. So I've been up close to the bots. I've taken them apart from, how they get an idea that when I have to look at someone else's design and make a simulation of it, I have to figure out how it's been put together. So that's the same thing I'm doing is I'm just applying the forensic skills that I've learned with industrial robots and applying it to the humanoid bots. Plus, I've had to do a couple of humanoids in our simulation package at the same time. So I have a rough idea of what the kinematics is going to be like.
So, yesterday we saw Boston Dynamics retires its remarkable Atlas robot. Now, you've had years to look at this. What would you guess this impressive, I suppose, beast actually cost? Is it millions?
Probably millions a piece. I think the latest time they said it might cost them around a quarter million to build, but I'm not sure. I'm sure with all the R&D easily, they were close to a million a pop. And it was never really designed for mass production. It was meant as a platform, R&D. Let's remember, it was a decade old of the design, going back. And at that time, that was really what the technology was that allowed you to be able to pull this trick off.
Mm-hmm.
But we've got a technological convergence now, which means it's really an outdated approach. And industrial robotics started that way too. They started out hydraulic and eventually went all electric.
Okay. Now, the problems with it were that it was expensive. It was never designed, it was designed with one purpose in mind, and that was the next fundraising round for Boston Dynamics. And it was a
Hmm.
resounding success. The videos they presented were heavily edited. And it clearly took so many takes that even the employees in the background were bored. So what we've got is stuff like this. Boston Dynamics unveils new Atlas robot. It's different. It's got
Yes.
now I saw another video you were on where you were discussing all the scuff marks, showing that this has had some significant wear and tear. What do you make of this guy? What are we looking at here?
Well, we're looking at them learning from all the design mistakes of the past and maybe carrying a few forward. So, the first thing is that they've been in the electric robot space for a while, just not with the humanoid bot. So, Spot is electric, also Handle is electric. So, they know how to build it. Um, let's say they were telegraphing that something like this was going to be coming. I mean, they were even trashing their own bot,
Mm.
bot Atlas, saying it wasn't for commercial, it was too expensive, everything else. And so they were their own best critic in many ways. And they knew they had to go all electric. And they're just very good at keeping everything close to their vest on what they were going to do. And it was one of those things when we saw the retirement yesterday. Did you feel like you're just waiting for the other shoe to drop?
Of course. That was the
Yes.
whole I reached that's the whole reason I wanted to get you on was I thought, "Oh, I've got this great idea. It's obvious that they're going to be moving forward with something that can be produced." And then
Hmm.
of course they stole my thunder because that was the plan all along.
You know what they should have done? Because they're Bostonians. They should have waited till Friday the 19th. The 19th is Patriots Day, also known as Lexington Conquered, the day, the shot heard around the world.
Oh.
They should have waited till then. But then again, the idea of revealing a robot that marks the anniversary of a revolution, maybe not.
Now, do you know what the face reminds me of? Uh,
Uh, two things.
this.
Two things. Okay, that's the third thing. Kind of a portal, reminded me of that. Reminded me of a bathroom mirror, and also
Oh,
reminded me of the robot in the new Lost in Space series.
okay. I don't care what you do with the head. I'm
Mm-hmm.
fine with whatever. I liked Figure's approach where you've got basically a status indicator. I think that's great. I think that's probably going to be a thing because
And
humans.
that's a status indicator too. Yep.
Mhm. Um, First guess. So I've watched the demos. I'm sure it's playing at various points in B-roll on this video. It is. It looks good. It looks impressive. It looks capable. It looks like they have learned a lot of lessons. Do you see any glaring problems with it?
I like everything above the elbow, but not below. So their wrists and their hands. So you'll notice the hand design that they have is actually very similar to the one they revealed about a month ago when they showed. So you see those fingers, it only has the three fingers. And these fingers are actually double jointed. So if you might remember from the video that they had a month ago showing it lifting up those struts,
Okay.
right? Remember the shock absorber struts that they were
Yes.
picking up with the old Atlas. So they have that same design, and the whole wrist and everything is just way too bulky. It can be improved. So Optimus has a much nicer wrist, and some of the other robot manufacturers have. Figure's got the same problem with their wrist. It's a big bulky wrist, but Figure actually has a proper human hand. But they did mention in their press release that they plan on having different gripper designs and whether they're going to have a full human hand or not. So that tells me this is more of an industrial application than an in the house application. They're
Oh,
designing it for
sure.
that. But once you
Sure.
go up from the elbow to everything else, I like a lot of the changes that they've made, including everything on the waist and all that. So that's like the only part. The lower arm, that's why I'm saying they could have learned a little bit from the lessons of the past there. But they've done a very good job of looking at what everyone else has done and taken the next step of doing. Would you say this is a double jointed robot or a robot with extended range?
So I don't know the definition of double jointed, but because it can flip around, it is
Ambiguous.
unidirectional,
Yeah.
ambiguous.
Yeah.
Yeah, it's
Yeah.
uh,
Ambidirectional. I don't know.
ambidirectional. Yeah, and that makes sense. I tell you one thing I thought we would see on these kinds of robots is additional arms, even little ones to hold the ladder while it's using two hands.
Maybe. Yeah. You mean like little T-Rex arms?
Yeah, little
Okay.
T-Rex arms down in the rib cage.
Yeah. You could potentially now, to be double jointed. I mean, you're talking about like hyperextension of your elbow and of your knee. Now the knee clearly cannot be hyperextended because of the linkage design there. It
Hmm.
can't. The elbow, because the elbow actually is an actuator. It's both the joint and the actuator. It should be able to. They just didn't show it off. What they did show is that they can go extra range on the movement of a lot of the joints, which is why suddenly the legs can flip around. And what's really cool is that when it walks towards you, everything turns in direction except for the hip. So basically, if you put a
Oh,
sticker on one side of the hip, it would always be pointing in the same direction. Yet the knees go in a different direction, the torso goes a different. All that kind of moves around.
huh.
So it's able to pivot
Oh, I see.
really quickly. Yes. So,
Oh.
and potentially they could do the same thing with the arms because the arms are so symmetric. They could probably flip them around and it could be sitting in the front typing on something over. Well, it can't type because I have the fingers, but let's say it's doing something here. Now it wants to do something behind it. Rather than turning the whole body um, at all, they could probably just take the hands and flip them around like this and do that. And the torso could still be pointing.
And
So
it has an owl head.
yes, I guess you could say it has an owl head. And unlike some of the other bots, there's actually something in there. It's not an airhead. If you
What's in
look at
there?
it a bit closely, and part of my reasons for thinking that is one of the first things I noticed is all the air vents throughout the
Hmm.
bot everywhere. So they definitely have cooling needs. And in the head, you can see there's also a pretty big vent. Now, you could say, well, they just put holes in there, Scott, because they want to reduce the weight of that because they're so weight sensitive. I'm like, Brian, would you poke holes in that just to reduce the weight? No, no,
No.
they need airflow. And so yes, they got probably some cameras hiding behind the glass there in the mirror or whatever it is. but they don't kick out a whole lot of heat. There's something up there you got to cool down. It looks like they have a Wi-Fi router in there. Herbert was wondering about why the antenna when no one else has it, and I'm just like assuming industrial grade communication, perhaps, because in a factory, it can be pretty noisy in there. And if you want to make sure that your signal is not being interrupted by anything else, maybe you do need something like that. The other possibility is they may be moving some of the electronics that would typically be in your torso up into the head,
Huh.
right?
Huh.
Now,
Sure.
you may not want to do it for weight reasons, right? It's going to be excess weight. And the head only spins this way, so it doesn't have that to worry about. So it still can carry a heavy load. And what happens if you take some of the electronics and CPU out of the torso and move it up there?
I don't know. What? You free up
You,
body space?
exactly. So basically, that means you've now got more room in your fridge, right? So we've
Yes.
decided, whoop, we're going to move everything out. Now, the other thing that I've always found interesting is the design of the torso. So if you look down at the bottom, how they get this torso movement,
Yes.
we've seen that one place before. So
Uh,
this
that
is a design that has not gone to waste.
God, Scott, you're killing me.
Or maybe it has. It's gone to the waste. Okay. So it's a wasted design, or it's not a waste. It's whatever. And when we get a close up, when you come in really close, you're going to see that they use actually parallel kinematics as opposed to serial kinematics to be able to solve that problem.
Hmm.
Now, what they've done is I wish they would use that same approach on their wrist. Instead of the wrist, they stacked up all these motors next to each other, right? That
Right.
means the wrist, the rotation that you want to everything on the wrist is taking up this much length, like the length of your lower arm to be able to accomplish that. If you want to have a spine, which is able to like move around, stuff like that, the other bot manufacturers have done the same thing. They stacked a bunch of them in there. Now, if your whole lower spine is that long, what does that do to your torso, your upper torso?
Well, it makes it very occupied and busy. It makes it
It eats it up.
full.
Yeah,
Yeah.
it's like suddenly it goes up there. And that's why if you look at some of the other bots that are out there, they have a very high torso. And it's like, where do you put your batteries if everything is a spine? So by doing that, they've got a pretty good sized torso volume there that you can start to stick your batteries in there. And then maybe you move some of your other components out somewhere else. And
Interesting.
who knows, they may be offloading a lot of compute because it seems like they're concerned about overheating because there are vents everywhere, back of
Sure.
the elbow, everything else. Now, do you think the motors produce the most heat?
No, it'd be the compute, I would think.
Yes, and you are correct because I had a chance to speak with Nathan Peterman, who was formerly of Agility, and he was saying in the early days, because I was trying to get from him, it's like how much power these things. He says at the beginning, it turned out that the cards that they had on there, the control systems and those actuators, was actually consuming more power than the actuators themselves.
Hmm.
And that stunned me. I was like, what? Really? He says, yeah, they couldn't believe it. And they had to go in there and try to really set down. So that tells us that, yeah, there's a certain amount of heat generation.
Hmm. Crazy. The average brain uses something like 100 watts.
Yeah.
Mine uses more like 80, and I like to say it's because it's really efficient. Now, I have no idea what the power consumption of my individual brain is. So what we're saying is Atlas, even at scale, even if they could have made them in huge volume, still would have been very prohibitive in terms of its cost because of its
Absolutely.
complexity, because of the engineering from day one, where this could be, look at it. It is not an overcomplicated monster.
Is it going to snag on anything? I mean, Atlas had all these things that was just going to get hooked and caught on everything,
Oh,
things
yeah.
protruding out. And do you know how much Atlas weighed?
100 pounds?
To 196 pounds.
At
And you know how
411?
at 411, exactly. That thing is heavy.
That's a
So
bulky.
if that fell on you, it was going to hurt.
Yeah.
This is lighter. I don't know how much lighter.
What should this robot weigh?
Okay.
150?
I think maybe a little lighter. Tesla is going for, I think, what was it, like 50? I think somewhere around 130 pounds is what most of them are targeting, somewhere in that area. The
Reasonable.
X1 bot is 30 kilograms, which is incredible. It's like 66 pounds.
Ooh.
And they
Oof.
say the reason they targeted that is they want it to be in the home. And in the home, you have to be that light. This,
Yeah,
I don't think is that light. And so the thing is, we don't know how tall it is. It's really hard to judge the height from this.
it is.
Herbert thinks it's pretty short. I'm guessing it's taller than the original Atlas, so it's more than 5 feet. Most of the others are around 5'6". I think the tallest one is Unitree around 5'9". So it's going to be somewhere in the mid, five something, 5'3", 5'4", somewhere around there
Sure.
for sure.
So I'm thinking, it is impossible to know based on the way this is framed. It was fun when you saw the shock absorber demo, and the first thing you did was message me and said, "What building is this? Where is this
Yes.
located?" And I said,
Yes.
"Unbelievable that you would ask me, but I do happen to know."
And it was, of course, Boston Dynamics.
It was the
Yes.
Boston Dynamics demo
Yeah,
lab.
because they do have an impressive lab that can fool you and almost look like a production line
Oh yeah, it can look
because
like
of,
anything. It's a good
yeah, yeah.
space.
Now, what we could potentially use is you see they have those squares down at the bottom on the floor that
Yes.
they
Oh
use
sure.
for their little romper room because they're falling down all the time.
Yes.
If we have an idea of how big those squares are, we might be able to tell. So we have at least one reference.
Yeah. I'm of the mind that it is also very small, that it is
Mhm.
also maybe 5 foot ish. I don't think it's big, but
It's definitely not 6 feet. It's not 6 feet. I'm thinking if it's below 5 feet, I think it won't be of much value because one of the problems with Osmo is that it was too short. It was like
mhm,
four something. And so
mhm,
it was like below the 5 percentile. So if you think about it, going in and doing human task was almost too small. So if
yeah.
that's what it's supposed to do, you want to aim for that. Now, let's remember this is owned by Hyundai. And they said in the press release that they plan on using it in, some pilots in Hyundai automation around there. Hyundai has plants in the US, correct?
Yes.
They also have them in Korea.
Yes.
And so the thing is that whenever you start looking at ergonomic studies and stuff like that, and people start throwing out fifth percentile, 50th percentile, 95th percentile, you have to say, well, which population group are you talking about?
Right.
Because every country is a little bit different. So when they're
Right.
designing these bots, they're trying to figure out, are we designing it for, the US demographic set or some worldwide set? And so I would think
Yeah.
you'd want to be taller than 5 feet, but you don't want to be 6 feet. So I imagine in Korea, they may be designing their ergonomic workspaces to be a little bit smaller than typically you would see in the US because the demographics will be shifted just a little bit as far as the size. And so you want to make sure that, okay, do we have to have two different sizes of this bot or do we want to have one size that we know is going to work in both? So what do you think?
Well, I think if you were going to put these in a factory in Norway, they might need to be 7 feet. So,
Yeah. Yeah.
yeah, and absolutely, the fifth percentile here is going to be different than in other countries, and there are definitely regional differences based on a number of factors.
Yeah. And you're
So,
always designing between fifth and 95th percentile within a
oh,
population group. But now you don't have to worry about that because all the bots are the same size. So the thing is, if I'm designing a workspace, I have to be within that specification. And then, but so you just like look for overlaps between all of them and say, well, where is that? And maybe it's
yeah,
5'4" or 5'5" for kind of like this global average of where you're going to be able to fit in, and then you don't have to worry about it.
that's very fun. So, this ballpark thoughts at scale. What is this talking about here? 50 grand cost, not
Um,
price.
it's going to come down to the motors, and they've put a lot of effort in designing the motors. That's the thing that they mentioned, and we just don't know how much it costs to build an actuator. Um, I didn't do a full actuator count, but I think it's also in the order of 40, something like that. Well, we're not, they don't have the full hands there. So structural actuators about 30. So if you're doing 1,000 a piece for that, that's already 30,000 in actuators. And then you have
Mm,
everything else you throw on. So
mm. So
I
more like
think they should be able
60,
to do it.
70.
Yeah. So I think, definitely under 100. They should be able to mass produce this under 100 and someday scale it down more. And whether they have the margins or they're able to do the design. And for the most part, they've done a really good job at hiding the cabling. So I mean, it's like they've really put thought into how to build this thing so everything's nice and smooth. They also did a few things that I noticed in one of the hip actuators. I think they have like a single housing with two um, degrees of freedom coming out, or two different axles.
Hmm.
Whereas Tesla has always stacked them together. You take one and you bolt the other one on. So we're producing the same actuator and we stick it together. But when you look down on that lower hip area, you will notice what appears to be kind of a combined actuator because it looks like they're either designing for mass or scale or something like that to be able to make it a little bit cheaper. That's actually something I'm hoping Tesla's going to do because at Tesla, if you look at the pelvic girdle and the way they have everything designed there, there's definitely places in there. So if you look right in that hip area, you will see basically there's a motor that's coming down that's making the knees go left and right,
Okay.
not forwards, backwards, left and right. And there's also the black circle that you kind of see in there.
Sure.
That's also like another degree of freedom. And both those appear to be sharing the same housing. And I'm pretty sure the motor for that vertical rotation is actually in that housing and not in the lower leg. Because in the lower leg, that seems to, or the upper leg, I should say,
Yeah.
just below there is a really big rotary actuator in there that is for the knee joint. So the knee joint is using a connecting rod to be able to actuate the knee. There is nothing actually built in the knee. That's why I say mechanically it couldn't be double jointed, because when you have a connecting rod, you really can only rotate one way. The elbow is the opposite. The elbow is not like the Tesla bot, which has a connecting rod. It actually has a really big built-in actuator there.
Wow.
And then they have that big long actuator stack. So how many of those actuators are common? That's the big question. Because if they're all different, your costs are going to go up. If you can make them, some of them the same, then you're going to get a little bit of scale out of that.
Yeah. If you can narrow it down to 5 or 6, probably would be a good sweet spot, you think?
Which is what Tesla did. And Tesla has basically 7, including the fingers, and 3 linear and 3 rotary. These guys have no linear. They've got rotary. They do have some linear actuation, if you want to call it that, but it's using a rotary motor. It's a trick that a lot of the others have done. They have a connecting rod connected to the part that's rotating up here that goes down here that then causes the rotation or actuation down below through a little lever arm. They're doing that down at the ankle, like everyone else, because that is really the best design. And they've got them hidden inside of that housing, so you can't see how it's being done. But if you look really closely, you'll see these little connecting rods. You can see it on the knee, and we can clearly see it on the torso, because when you get that close up when it walks right up to the camera like this, you look right down that torso, you will see that, and it's the same mechanism that Figure is using. But that's being actuated with linear drives. So, not linear, rotary drives. I don't think there is one linear drive out there. So they've decided to do that.
Right there. Okay, so guys, in the comments, what did we miss? What did we misunderstand? What additional questions might you have about it? Ask away. We shall consider answering them. But I don't know. Should I have him back maybe tomorrow or the next day to talk about who the actual winners and losers in robotics are, and if it's too early to know? Guys, like, subscribe, do the usual things. Stay tuned, stay juicy, and I cannot wait to hear from you clever robots the next time I get Scott back.
And the clever humanoid robots.
The clever humanoid robots. What a serendipitous slogan I came up with accidentally all those many years ago.